Hi everybody, today we are going to do exponential functions and talk about exponential growth. So first off, an exponential function involves the expression b to the x power where the base is b, which is a positive number other than 1. All exponential functions have asymptotes. Remember, an asymptote is a line that a graph approaches but never touches, okay? All right, so first it says to fill in the table and draw the graph for y equals 2 to the x power. So we're going to take these numbers and plug them into the exponent right here. So 2 to the second power is 4. 2 squared is 4. 2 to the first is just 2. 2 to the 0 power, anything raised to the 0 power always equals 1. Okay. 2 to the negative first. This is actually the exponent rule. To make that exponent positive, you write it in the denominator. So this is 1 over 2 to the first is 2, so 1/2. Same idea here. This will give you 1/4. And you can type these into your calculator if you're unsure, and 1/8. Okay, for an example, whoops, I could do 2 to the negative third. Fraction, get 1/8. Okay, so quick little review there. All right, so now let's graph this function. So 1, 2, 1, 2, 3, 4, 1, 2, 0, 1, negative 1, 1/2, negative 2, 1/4. Oh, it's getting smaller and smaller right here, okay? So this is our function. Alrighty. Then it says, what is the equation of the asymptote? So notice how my graph, like it keeps going down here, but if we graph this in our calculator, if I do, what was it, 2 to the x power? Let's graph that just to see what it would look like. Yeah, see, like the graph doesn't go below the x-axis. So we have an asymptote at y equals 0, that's that line, or you could say the x-axis, okay? But I want you to write down the equation, okay? I'm asking for the equation, so make sure you write that down. All right? So the graph approaches the x-axis but never touches it. That's why it's an asymptote. All right. Now we're going to talk about what this a value out in front does. This a value out in front is actually going to be your y-intercept, okay? The b value, I don't know why that's on there. We need to cross that out. Sorry about that, okay? So it says graph each and answer the questions below. So let's think about this. If I plug in a 0 right here, okay, that's how I find my y-intercept, right? 2 to the 0 power is 1, right? 1 times 8 is 8. That's why this is the y-intercept. So 1, 2, 3, 4, 5, 6, 7, 8. All right, but let's go ahead and type this into the calculator to get a better picture. Let's look at the table of values. So at negative 1, I have 4. 1, 2, 3, 4. Negative 2, 2. Negative 3, 1. And it looks like it stays above that x-axis. So let's just draw a quick sketch like that. All right, good. So the domain of this graph, well, as I go to the left and to the right, it just goes on forever, so it's all real numbers. Remember, these are the x values, range is your y. My y values are all above the x-axis, so they start at 0 and go all the way towards positive infinity. Now we're going to use brackets on parentheses on both of those because the point's not included. And then you always use a parenthesis with the infinity symbol, okay? All right, my asymptote is at y equals 0, which is the x-axis. And then my y-intercept was 8. Is the function increasing or decreasing? Well, as I read my graph from the left to the right, my function's going up, so it would be increasing. Okay? All right, number 2. Ooh, got some extra funky stuff in here. Let's type this guy in. Let's see, 4 to the x minus 1 minus 3. Let's just see what that looks like. Sorry for the glare from my light bulbs. All right, so this asymptote is not at the x-axis. It looks like it moved down a little bit, right? Well, let's plot some points here. Oops, second graph. All right, let's do 1, -2. 2, 1. Okay, 3, 13 is really big, so let's do these. 0, -2.75, -1. Okay, so it gets closer. It looks like it's closer and closer to -3. Yeah. So, looks like this. I'm going to connect those dots, okay? So my domain, again, it's all real numbers, goes from negative to positive infinity. You can either write negative to positive infinity, or you could write all real numbers. I'm okay with either way, okay? We can do that over here. Whoops. My range, it's all the y values that are greater than -3. So it goes from -3 to positive infinity. And we use a parenthesis because at -3, that point does not exist. My asymptote is at y equals -3. We can even draw that in, guys. Just make sure it's a dotted line because it's not part of the function. My y-intercept was at when x is 0, so that's at -2.75. And this function is increasing because as I go from the left to the right, it goes up. So increases. Goes whoop. All right, let's do one more. Number 3, let's type this guy in. So -3/2 to the x power. Let's just get an idea of what that graph looks like. Okay. Looks like the y-intercept is at -1, so 0, -1. We can actually go ahead and fill that in. Y-intercept's at -1. Then I have 1, -1.5, 2, -2.25. Okay. Let's do -1. That's about here. So it looks like it goes like this. Whee. Okay. All right. So my domain goes from negative to positive infinity again, right? My range is all the values less than 0, so it goes from -infinity to 0. And that's where my asymptote would be, right? At y equals 0. It's kind of hard to tell when it's on the x-axis if it's drawn in or not. In this function, as I go from left to right, my pen takes me down, so it's actually decreasing. Okay? So that's how we graph exponential functions. On the back, we're going to talk about a couple formulas we have. Okay? We got 2, exponential growth and compound interest formula. So exponential growth, this is the formula right here. Y equals a times 1 plus r to the t power. 1 plus r is the growth factor, like how much your function's growing by. R is your rate. This needs to be written as a decimal. In decimal form. And then your initial amount is your A value. So it says in 1990, tuition at the local university was $4,300. During the next 8 years, tuition rose 4% per year. Write a model equation for this information and find the tuition in 1998. So I want to find the tuition, which is the final amount. That's your Y value, okay? So I don't know what that is. The tuition currently was $4,300. 1 plus, it rose by 4%. So 4% as a decimal is 0.04. All you have to do is take the 4 and divide it by, whoopsies, by 100. Okay, that's how you can find that. And then T is after how many years? Okay, that's your time. So this is, it says to write a model for the equation. This would be the model. And then to actually find the tuition in 1998, instead of plugging 1998 in for t, I just want to know how many years from 1998 to 1990, which was a total of 8 years. So I'm going to plug 8 in for t. So I have y is going to equal 4300. 1 plus 0.04 is 1.04 to the 8th power. So let's type that into our calculator. So 4300, whoops, you guys can't see it. 1.04 to the 8th power. And we were talking about money, so let's go to 2 decimal places if we think about cents, right? So $5,000, $5,884.85. Okay? All right. Let's do another question. Given y equals 2,000 times 1.065 to the 5th power, what is the growth factor? What is the percentage of the growth? So the growth factor is within here, right? So the growth factor is this 1 plus r part. So growth factor is 1.065. And the percentage of the growth, we could find that by just like, this is basically asking for r. What is r, right? So to solve for r, I could just do 1 minus r to get that r value, right? So I'm going to take this and subtract it by 1. So I get 0.065. And that's it in decimal form. As a percentage, you multiply that by 100 or move this to the decimal 2 spots to the right. So this is 6.5% is the growth. Okay? So that kind of had you thinking a little backwards there. All right, last problem, compound interest formula. So this formula, A is still your final amount, P is your starting amount or your principal amount, you might hear us say sometimes. 1 plus R is your rate, still as a decimal, got rid of the decimal form. And then N is the number of times compounded yearly. Okay, so if something, that just means how many times that occurs. So something that occurs monthly, how many months are in a year? 12. So N would be 12. Okay. If you had, let's see here, weekly, there are 52 weeks in a year. What are some other common ones? A quarterly. How many quarters are in a year? There are 4, right? Semi-annually. Semi means half, so half of a year. There's two halves of a year, right? Those are kind of some common ones. We'll let you know in class if there's any additional ones you guys need to know, but those are the most common ones that are used. And then T is the number of times that happens per year. Notice that N gets plugged in the fraction and up here as the exponent, okay? So just be aware of that. All right, so an example of this is if you deposited $1,000 in an account that paid 8% annual interest compounded quarterly, how much would you have in the bank at the end of 3 years if you never deposited or withdrew any money from this account? I should say from. So let's see here. All right, so we need to find how much money in the bank will you have at the end of the 3 years. So we don't know what A is. We need to figure that out. That's our final amount. We start with $1,000 that we deposit into the bank. 1 plus the rate at which our money is growing by. We have an annual interest rate of 8%. So that as a decimal, I would move that 2 spots to the left. So 0.08 over my N value. It says we're compounded quarterly. So it's the number of compoundings per year. So compounded quarterly, there's 4 quarters in a year. So we're going to use 4. Okay. If that said monthly, we would use 12 and so forth. Then I'm going to plug N up in the in the exponent as well. And then T, it says at the end of 3 years. So I'm going to plug in a 3 right there. All right, let's learn how to type this in our calculator. So we've got 1,000, 1 plus alpha y equals, get that fraction guy in there, 0.08 over 4, to the 4 times 3 power. And again, we're dealing with money, so round to 2 decimal places to represent the cents. So 2, 4. So $1,268.24. All right, that's it. Get to your homework. Let us know if you have any questions.